Have you ever wondered why today's software projects seem so complicated? You open any modern application's codebase and it looks like someone mixed every programming language together. But this isn't chaos, it's actually a smart strategy. Look, a lot of people on the internet claim there's one best programming language. But here's the reality check. Every language has its own strengths and weaknesses. You can't do everything with just one tool, right? It's like cooking. You can't prepare an entire meal with just one utensil. You need different pots, different pans, different tools for different tasks. Software development follows the same concept. Every problem has its own nature, and each language solves specific problems better than others. Let's take a simple example. Inside the browser, only JavaScript or TypeScript runs directly, so if you want to create buttons, animations, or user interactions on a web page, you have to use JavaScript. It's the browser's built-in language, so front-end developers don't really have a choice. But the backend scenario is completely different. In server-side development, many factors matter: processing speed, memory management, handling concurrent requests, database operations, networking. Every language performs differently in these areas. Node.js is perfect when you need real-time communication, like chat applications. Go language is extremely fast for networking tasks, which is why it's popular in cloud services. Java is trusted for enterprise-level applications because its ecosystem is very mature. And Python, it has no competitor in data analysis and AI/ML. Look at big companies and you'll see how this approach works. YouTube's media player is written in JavaScript for the user interface, but video encoding and compression happens in C++ because it needs raw performance. Backend services are written in Python and Go. Netflix's backend infrastructure is based on Java for stability, but data processing happens in Python. Instagram uses Python for server logic, React for web interface, and mobile apps are developed in native languages, Swift for iOS, Kotlin for Android. These aren't random decisions, these are calculated choices. The interesting thing is that even within a single component, multiple languages are used, like machine learning libraries, PyTorch, or TensorFlow. You write code in Python because it's simple and readable. But when actual heavy computation happens, it executes in C++ or GPU kernels. Python gives you ease of use, C++ gives you blazing fast performance. This pattern is common in mobile apps too. Android development happens in Kotlin or Java, but where performance is critical, like game engines, audio processing, or image manipulation, C++ code is used through J. And now WebAssembly has expanded the possibilities even further. You can compile Rust or C++ and run it in the browser alongside JavaScript. Now the question is, how do these different languages communicate with each other? In modern architecture, APIs, message queues, and standard protocols are used. The microservices architecture has made this concept even more popular. Each service is independent, can be written in its own language as long as communication is standardized. REST APIs, gRPC, or message brokers like Kafka, all these connect different services. Your authentication service can be in Node, recommendation engine in Python, and data storage in Post. Docker and Kubernetes have made this even easier. Each service is packaged with its dependencies. Beyond performance, there are practical reasons for a multi-language approach. Teams and hiring are also factors. Data scientists prefer Python because they need NumPy and Pandas. Backend engineers like Go or Rust for concurrency. Front-end developers are comfortable with TypeScript. Letting each team work in their language of expertise means faster development and happier developers. Integration with legacy systems is also a big reason. You can't immediately replace old Java code, so gradually introducing Kotlin or Scala is a better strategy. But obviously there are challenges. Multiple languages mean maintaining multiple runtimes. Development environment setup becomes complex. Standardizing logging, monitoring, and deployment pipelines can be difficult. This is a shift from a single monolithic application to a distributed system. You get flexibility instead of simplicity. But complexity also increases. That's why good architecture needs clear boundaries, well-defined interfaces, and shared observability tools. So that was today's technical discussion on multi-language development. If you enjoyed it, please hit the like button and subscribe to the channel for more interesting videos. See you in the next video. Take care.